First, let's look at the setup for the system. The Ethernet cable is connected to the Ethernet shield attached to the microcontroller. A relay driver circuit made using transistors and diodes acts as an intermediary between the two relays used to control the two different devices. Relay A is connected to the device D1. The relay B is connected to the device D2. Overall, the system looks like this. Now, let's look at the mobile app which acts as the user interface for our system.
On opening the app, the user has to log in using the login screen. We have the option to select or add a new user or a new house altogether. All these values are coming from the database provided by the Google App Engine, as displayed on the left.
After logging in as an existing user, we have the option to manage or view devices that are currently connected to the system. On clicking on Manage, all the devices that are currently connected to the system are displayed. We can also add a new device by filling in the relevant details. Now if we select on an existing device, we can see that its current status is false. If I click on the toggle button, it will turn on the device. After syncing, the status is changed both on the database as well as on the app. Now, if I turn off the lamp, the status is synced and reflected at all the users that are currently using the app. As well as on the database. Now let's take a closer look at how the Google App Engine works. This is the dashboard for the Google App Engine. On clicking on the Data Store viewer, we can see the different fields associated with the database. Here are the different tables associated with the database. On the appliance table, we can see the different appliances and their respective fields. Currently, we have two devices, D1 and D2. The value of these fields can also be edited from the database, as displayed here. On changing the value from true to false, the connection of the device is also changed at all the mobile phones that are currently using the app. We have a separate column called as the timestamp that is used to calculate for how much time the device was being used. And using this value, we can calculate and predict the usage and consumption during the year. We can also see all the users that are connected or are using the app right now, and we can change their value. All these values are editable from the user interface or the web app. Now let's give a working demonstration of our entire system. User A on the right is trying to control device D1 on the right hand side using the mobile phone. On clicking on the toggle button, he turns on the lamp successfully. And it takes a little bit of time to sync the status with the web app and the other device in the hands of user B. User B now wishes to turn off that lamp, and he does that using his mobile phone. And the status is synced amongst both the mobile phones as well as the web app. Now he tries to control the device D2 with his mobile phone and successfully turns it on. Whereas user A does not like device D2 that much and wants to turn it off. Let's see if he can do that. Apparently he can, so the system works perfectly fine and both users are happy.